So, with that being said, we have a new question here. We have the molecular geometry is of BCl3, so that's boron chloride, if I remember correctly, is blank, and the molecule is blank as well. So with this one, actually, to be able to solve this question, we still need to know our Lewis dot diagram, okay? So if we look at our periodic table here to find out how many electrons we're working with, boron has 3 valence electrons, okay? And chlorine has 7 valence electrons. How did I figure that out? Is that boron is on the 13th column. To find out what electrons you have based on the 13th column to the 18th column, you have to make sure you just subtract by 10. So boron has 3, oxygen has 6, nitrogen has 5, things like that. So it only has 3. Chlorine, just as following that same rule, would be 7. So we have 3 plus 7 plus 7 plus 7. So that's 21 plus 3, that's 24. So we have 24 electrons total. Okay? So, molecular geometry of BCl3. In order to do that, we just have to drop Lewis dot. Okay? We're going to have the boron in the middle. And then we're going to just add these. And just a side note, boron can't follow the octet rule because it only has space to bond 3 things, okay? It'd be quite complicated for it to try to set up an octet rule. So we have BCl. So now the last Cl. And with that being said, we should hopefully be able to count it and say there was 24 electrons, which there is, so perfect. Now, the molecular geometry of this, alright, we need to find out actually the hybridization. So, hybridization is found by the things attached to it, including lone pairs and more importantly bonds, okay? So for boron, we have 1, 2, 3 bonds, okay? So it will be sp2 hybridized because the S takes up one of the bonds, and then p2 because there's 2 more bonds left. So that'll be sp2 hybridized. And now that we know that, we can actually look at our electron geometry sheet, and it'll actually give us trigonal planar. Okay. Funny enough, because there is no lone pairs here, when you try to find its molecular geometry, this is also correct as well. And now, for that being said, we were able to cover that part. Now, whether it's polar or not, let's see. What is the electronegative difference between chlorine and boron? So the electronegativity difference from chlorine is 3.16 and boron is 2.04. So without even doing the math, I can say for sure that the is going to be a polar molecule. I mean, not molecule, polar bond, actually. And with there being a polar bond, we have to now look at what if it's counteracted. So if it's trigonal planar, it means that everything is done in an even 120 degrees, okay? So if everything is just pulling from the root at 120 degrees each one, they actually all cancel each other out. So this is truly non-polar because of what they do when they cancel each other out, okay? And the molecular geometry discussed is indeed trigonal planar. Okay? So that is what I would do there in regards to this question. We now figure out the molecular geometry, whether it's polar, and I hope that was a good explanation for it, is that because the chlorines are all pulling on each side evenly, that is why it ends up being a non-polar molecule, even if its bond itself were polar. Okay, so now, with that being said, the only answer that works for this, whereas trigonal planar or non-polar, the answer is D. Okay, let's see how we did. Trigonal plane, nonpolar. Most structures like that, which is what we drew, and the distribution of electrons is what makes it nonpolar. So with that being said, the only one that worked for trigonal, planar, and nonpolar was indeed D. Okay. So with that being said, just quickly take a look